All right. So here are the sum and difference formulas for cosine. So there's a really big proof on how to find these. If you really want to know, ask me not now. They usually take about 45 minutes to an hour to prove. So just for your convenience, these are the formulas. Know them, okay? All right. So the first formula is cosine alpha plus beta can be expanded into cosine alpha times cosine beta minus sine alpha times sine beta. And then the difference formula for cosine is cosine alpha minus beta can be expanded into cosine alpha, cosine beta plus sine alpha, sine beta. So both formulas are very similar, except opposite operations, right? You see that plus, minus, minus, and that plus. Okay, so our goal is to find the exact values of these trig expressions using the sum or difference formulas. So I'll show you how these work. Okay, but let me do this real fast. Not double angle. Okay, cool. And you'll definitely need your unit circle for this. Okay, so find the exact value of cosine of 75. So I will start this off with the cosine of 75 degrees. And what we want to do is now take this angle of 75 degrees and break it into two angles that are actually on the unit circle. What two angles on the unit circle can add up to 75?
45 and 30.
There you go. So this now becomes a cosine of 45 degrees plus 30 degrees, which means we will now use the sum formula for cosine. And this is how it's going to work. This is going to become the cosine of 45 degrees times the cosine of 30 degrees minus the sine of 45 degrees times the sine of 30 degrees. Everybody cool with that? So again, we take 75 and we break it into angles that are actually on the unit circle. And now we use the unit circle again to multiply and evaluate and simplify this expression. What is cosine at 45 degrees?
Square root of 2 over 2.
Good. Square root 2 over 2. What is cosine at 30 degrees?
Radical 3 over 2.
Good. Minus, what's the sine at 45 degrees?
Square root of 2 over 2.
And what is the sine at 30 degrees?
1/2.
There you go. And now just multiply them together. Square root of 2 over 2 times square root of 3 over 2 is square root of 6 over 4 minus square root of 2 over 2 times 1/2 is square root of 2 over 4. And I think my math lab makes you put them together as one whole fraction. So it'd be square root of 6 minus square root of 2 over 4. Any questions on that? And that is the exact value of the cosine of 75 degrees. Because do we see an actual value for 75 degrees on your unit circle?
Yes, sir.
No, but this is it. This is that exact value. Okay. Everybody good?
Yep.
Okay. Let's do it again in radians. All right. These ones a little tricky, not too much though. So find the exact value of the cosine of pi over 12. All right. So we wanted to take pi over 12 and break it into two angles that are on the unit circle. And what may help you is first figuring out how to get pi over 12. Like what two fractions added or subtracted can get you pi over 12. And one of the easiest ways to think of that is just say 4 pi over 12 minus 3 pi over 12. Will that give me pi over 12?
Yeah.
Now reduce them. What does 4 pi over 12 reduce to?
Pi over 3.
Pi over 3. And what does 3 pi over 12 reduce to?
Pi over 4.
Are those radian values on your unit circle?
Yes.
Whoa, crazy, right? All right. And now we're going to use the difference formula for cosine. So you'll get cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 and the the sine of pi over 4. All right. So we broke it down. We took pi over 12, split it into two angles, got to use the difference formula for cosine. Now more unit circle work. What is cosine at pi over 3?
1/2.
1/2. What is cosine at pi over 4?
Square root of 2 over 2.
Good. What is sine at pi over 3?
Square root of 3 over 2.
And what is sine at pi over 4?
Square root of 2 over 2.
There you go. Put it together and you get square root of 2 over 4 plus square root of 6 over 4, which is square root 2 plus square root 6 over 4. Very similar to the one above, right? Okay. Any questions on that one? All right. One more time for cosine. Here we have the cosine of 7 pi over 12. What two values could we break that into? What two fractions added together could make 7 pi over 12?
3 pi over 12, 4 pi over 12.
That's it.
Wasn't that just what we used?
Exactly.
Pi over 4 and pi over 3 or whatever.
Yep. And now we reduce those and you get cosine of pi over 4 plus pi over 3. And we're using the sum formula for cosine. And we'll get cosine pi over 4 cosine pi over 3 minus the sine of pi over 4 times the sine of pi over 3. There we go. Everything's broken down. Now let's use our unit circle. Cosine of pi over 4, what is that?
Square root of 2 over 2.
Cosine pi over 3?
1/2.
1/2 minus sine of pi over 4?
Square root of 2 over 2.
Square root 2 over 2. And sine of pi over 3?
Square root of 3 over 2.
Bam. Put it together. Square root 2 over 4 minus square root 6 over 4. And we get square root 2 minus square root 6 over 4. Boom, boom, boom. All answers very similar, right? Okay.
Yeah.
Those are the sum and difference formulas for cosine. So you just take your angles and you break them into angles that are on the unit circle. All right. Which means now we have the sum and difference formulas for the sine function. So here, sine of alpha plus beta is equal to the sine of alpha times cosine beta plus cosine alpha sine beta. And then the sine of alpha minus beta is sine alpha times cosine beta minus cosine alpha sine beta. All right. Perfect.
So these only differences is, so for sine, you keep the signs the same, but in cosine,
Exactly.
swap them.
Well, the formulas are definitely different though. So yes, plus, plus, minus, minus, but this is now sine, cosine, cosine, sine. The above was cosine, cosine, sine, sine. Yes, yes, yes. Okay. And we do the exact same process for sine. So the sine of 7 pi over 12 can be broken into the sine of 3 pi over 12 plus 4 pi over 12. Reduce, and you get the sine of pi over 4 plus pi over 3. And now use the sum formula for sine, and we get the sine of pi over 4 times the cosine of pi over 3 plus the cosine of pi over 4 times the sine of pi over 3. Perfect. Okay. And now unit circle sine of pi over 4. What is that?
Square root 2 over 2.
Cosine of pi over 3.
Half.
Half. Plus cosine at pi over 4.
Square root 2 over 2.
And sine at pi over 3.
Square root 3 over 2.
There you go. Put it together. Square root of 2 over 4 plus square root 6 over 4. There we go. Okay. So same process, different formula. Okay. And now if you didn't know, you can reverse engineer these properties. So you can work them backwards. All right. So that's what we're going to do in the next one. You have the sine of 80 times the cosine of 20 minus the cosine of 80 times the sine of 20. Which formula does that look like? The first or the second one above?
That looks like
Second.
The second one. Good. Which means that this formula will now just be rewritten or condensed into the sine of, here's alpha, here's beta. It's going to be the sine of 80 degrees minus 20 degrees, which gives me the sine of 60 degrees. And what is the sine at 60 degrees?
half. Oh wait, no, that's
Radical 3 over 2.
There you go. Fun stuff.
So wait, you didn't have to do the second part of that?
What second part?
The minus cosine 80 sine 20?
No, we technically can't, because do you see 80 degrees on your unit circle?
Yeah.
No. So the only way to do that would be to use your calculator. But why do that when you can just reverse the formula and get the sine of 60? So what we're also saying is that if you did punch this in a calculator, you would get the same exact result. So we're just working it backwards. All right. Now for this one, cosine of 70 times the cosine of 20 minus the sine of 70 times the sine of 20. Would this be the sum or difference formula for cosine?
Difference.
Well, there's a difference, but remember in
Oh,
cosine,
no,
the
some.
signs are opposite. Good. So this would become the cosine of 70 degrees plus 20 degrees, which would give me the cosine at 90 degrees. And what is the cosine at 90?
0.
0. Cool. And D, sine of pi over 12 times the cosine of 7 pi over 12 minus the cosine of pi over 12 times the sine of pi over 12. This looked like the sum or difference formula for sine. Difference. So you'd get sine of pi over 12 minus 7 pi over 12. And you'd get the sine of negative 6 pi over 12, which reduces to what? Negative pi over 2. So you'd get the sine of negative pi over 2. But sine is what type of function? Even or odd? Odd. So I can rewrite this as negative sine of pi over 2. And now, what is the value of sine at pi over 2?
1.
But what's waiting on the outside?
Could we also just do the sine of negative pi over 2? Because then you just go the opposite way, which would be a -1.
That's it. Yeah, you can think of it either way. Because sine of negative pi over 2 would be coterminal with 3 pi over 2, right?
Absolutely.
However you want to think about it. But for you, Ethan, even and odd, because you didn't remember it.
Wow, thanks.
You're welcome.
The math equivalent of a dunce cap.
There you go. All right.
With a whole bunch of equations written on it.
Okay. Find the exact value of secant of pi over 12. Okay. Well, we don't have a sum or difference formula for secant, but we know that secant is the reciprocal function of what?
Cosine.
Cosine. So this would become 1 over the cosine of pi over 12. And now we can break the cosine of pi over 12 down into 2 separate fractions. We did this before on the first page. You can make this the cosine of 4 pi over 12 minus 3 pi over 12. Would that give me pi over 12?
Yes.
And now you'd have 1 over the cosine of pi over 3 minus pi over 4, which means now we can use the difference formula for cosine. Let's get crazy. You get 1 over cosine of pi over 3, cosine of pi over 4, plus sine of pi over 3 times the sine of pi over 4. Woof. Equal to 1 over, and unit circle time, what is cosine at pi over 3?
1/2.
1/2. Cosine at pi over 4.
Square root of 2 over 2.
Sine at pi over 3.
Square root of 3 over 2.
Square root of 3 over 2, and sine at pi over 4.
Square root of 2 over 2.
All right. This is starting to look great, right?
Absolutely.
And you'll end up with square root of 2 over 4 plus square root of 6 over 4 which gives you 1 over square root 2 plus square root 6 over 4. But now you have a fraction in your denominator, so you must multiply by the what?
Denominator of the denominator.
Reciprocal.
Reciprocal. So all you're going to do is flip this guy. And you'll get 4
Ugh.
over square root 2 plus square root 6. But can you leave it like that?
No, so we're gonna have to do the conjugate.
You multiply by the conjugate. What's the conjugate?
Square root 2 minus square root 6.
Good. Perfect. See, we left trig a long time ago. The last trig we did was there. Everything else here is algebra. Which means you'll get 4 times square root of 2 minus the square root of 6 over, and when you FOIL these two, well, will you have a middle term?
No, still cancel.
No. Good. So what's square root of 2 times square root of 2?
2.
2. No middle term. And what's square root of 6 times square root of 6?
6.
6. Good. 4 times the square root of 2 minus the square root of 6 over negative 4. Your 4s will cancel. And then, I guess I should do this. You'll have square root of 2 minus square root of 6 over negative 1. You bring the negative up, and it will change your signs. And what's our final answer?
Square root 2 plus square root 6. No.
Negative square root 2 plus
yeah,
square root
negative
6.
Square root 2
Good.
plus-
Or how about just square root 6 minus square root 2?
Or
There
could
you
you technically just leave the negative outside and have that in parentheses?
No,
Yeah, but that's not simplifying, right?
no. Just distribute that negative. There you go. Square root of 2, square root of 6 minus square root of 2.
Man, what a sexy problem.
That was great, right? All the trig and algebra fun you could have.
I love how these problems start to get longer and longer every time.
Wow, we're not even there yet. Maybe not even in this class, right? Okay. Cool. Okay, so there you go. Now we have, if cosine is equal to 1/4 in quadrant 4, find the exact values of sine theta minus pi over 6, and cosine theta plus pi over 3. So what we're going to do here is make our unit circle based off the information given. So here is my unit circle, and it says cosine is in quadrant 4, or theta, sorry, theta is in quadrant 4. So that means I should draw my triangle first. So we are in quadrant 4. Here's theta. And if cosine is 1/4, how do I label this triangle?
The hypotenuse is 4, and then theta, and then the x is 1.
Good.
And then do Pythagorean theorem.
And then by Pythagorean theorem, you'll
It should be
get
negative, right?
Oh yeah, it will be negative, yes, but the height will be what? 16 minus 1. So do you get the negative square root of 15?
Yep.
All right, cool. There we go. Now we can continue. What is the sine of this theta?
Negative square
Negative
root of
radical 15. Or 4. Sorry, bro.
Negative square root of 15 over 4. Good. And now using the same theta, we need to know what is sine of theta minus pi over 6. So now we're going to use the difference formula for sine here. So this is going to be sine theta cosine of pi over 6 minus cosine theta times the sine of pi over 6.
So
Okay.
sine alpha, that's going to be what sine is. So the negative square root 15 over 4.
Exactly.
Okay.
So this sine theta relates to this triangle, which we already found that value here. So like you said, sine theta becomes negative square root 15 over 4. What is cosine at pi over 6?
Radical 3 over 2.
Good. Minus, what is the cosine of this theta?
Negative square root 15. Oh, wait, no, because it's the theta of the, oh, so just 1/4, right?
There you go. It's even given at the in the problem, right? Look at that. Cosine is 1/4 right there.
You tricked us.
That's like literally the only I thought I had to think of that too.
What is sine at pi over 6?
1/2.
1/2. There we go. Put it all together and you'll get negative square root 45 over 8 minus 1 over 8. Okay, but does the square root of 45 break down?
Probably.
3 radical 5.
Good. You can break this into 9 and 5, and you'd get 3 radical 5, right?
Yeah.
So you'd get negative 3 radical 5 minus 1 all over 8. So ugly. Okay, good with that?
Yeah.
Yeah. And now we have cosine theta plus pi over 3, which means we're going to use the sum formula for cosine. So this will expand to cosine theta times the cosine of pi over 3 minus the sine of theta times the sine of pi over 3. Okay. And based on the triangle above, or what was given in the problem, what is the cosine of what is the cosine of theta?
1/4.
1/4. What is cosine at pi over 3?
1/2.
1/2. Minus, what is the value of our sine?
Negative radical 15 over 4.
Good. And what is the value of sine at pi over 3?
Square root 3 over 2.
There you go. Beautiful. Put it together and you get 1/8. And look at that, minus, minus. So we're going to have what?
Plus.
Plus. And we know that you'll get square root of 45, but we know that becomes what?
3 square root 5.
Good. I got to put these together anyways, right? 1 plus 3 square root 5 over 8. Done and done. All right. Any questions on that page? Holy crap, we got so much more to go. All right, let's keep trucking then. All right, next. Use the sum and difference formulas to find exact values. So this says if sine alpha is 4/5 and alpha is between pi over 2 and pi, And sine beta is -2 square root of 5, where pi is between, or beta is between pi and 3 pi over 2. Find cosine alpha, cosine beta, cosine alpha plus beta, and sine alpha plus beta. Oof. All right. So got our work cut out for us. Okay. So what we're going to do is we have to create triangles for each theta. So, or each angle. So we need to create a triangle for alpha. We need to create a triangle for beta. So let's start with alpha. So here is our triangle, not our triangle, our unit circle. And if we are between pi over 2 and pi, what quadrant are we in?
2.
Good. So we're between pi over 2 and pi. So this means alpha is, I keep drawing that, hang on. Alpha is in quadrant 2. So here's alpha. And then the next piece given is that if alpha is 4/5, if sine alpha is 4/5, this means that the height of the triangle is 4, the hypotenuse is 5, and what would the base of the triangle be?
-3.
-3. Good. It's a 3, 4, 5 triangle. Okay. Now we're going to do the same for beta.
Is that that thing all the way on the left? Is that supposed to be alpha?
Yeah, it's alpha.
Ishy.
No offense, I just didn't see it at first.
Whatever, man. All right. So if beta is between pi and 3 pi over 2, what quadrant are we in?
I'll let someone else answer.
3.
We're in quadrant 3.
3. Good, 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 Roman. All right. There's beta. And if cosine is negative, not cosine, sorry. If sine is -2 over the square root of 5, this means that the height is -2 and the hypotenuse is what?
Square root 5.
Square root 5. And then by Pythagorean theorem, the base is going to be what?
-1.
-1. Good. Okay. We have everything figured out for alpha and beta, which means we can now find what it's asking of us. And we will reference our triangles. So let's say A. What is the cosine at alpha?
-3/5.
Good. -3/5. B. I'll go here. Sure. What is the cosine at beta?
-1 over radical 5, which would be
Negative square.
negative radical 5 over 5.
Good. And now time for the sum formulas for both functions. C. What is cosine alpha plus beta? Which means you'll get cosine alpha, cosine beta, minus sine alpha, sine beta. And now all we have to do is, again, reference our triangle. Actually, I think we have all those values already, right? We might. So what is the cosine at alpha?
-3/5.
Good. -3/5. What is the cosine at beta?
Negative radical 5 over 5.
Good. Minus, what is the sine at alpha?
4/5.
4/5. And what is the sine at beta?
-2 over radical 5.
Good. So we should probably just rationalize that already, right?
So it'd be -2 radical 5 over 5.
Yep. There we go. And then multiply them. You'd get +3 square root 5 over 25. And then you see negative, negative again. And we get plus 8 square root 5 over 25. Right? Yeah. Okay. And now they have the same denominator and these have the same radical. So you can add the coefficients in front. What's my final answer?
11 square root 5 over 25.
Good. 11 square root 5 over 25. Yeah, so gross. Okay. That's how that works.
Friends.
All right, cool. All right, and then we just need to do it again for the sine function, sine alpha plus beta, which I ran out of room, so we'll just do it there. D. Sine of alpha plus beta, and we will get, I can't even write, there we go, sine, sine alpha cosine beta plus cosine alpha sine beta. And once again, just reference your triangles. And what is the sine of alpha?
4/5.
4/5. What is the cosine at beta?
Negative square root 5 over 5.
Good. Plus, what's cosine beta? No, sorry, cosine alpha.
Negative 3/5.
Negative 3/5. And what is sine beta?
Negative 2 square root 5 over 5.
Beautiful. Put it together and -4 square root 5 over 25 minus minus, that's plus. So 6 square root 5 over 25 and add them together.
That should be 2.
2 square root 5 over 25. Perfect. All right, not bad. So that's how you handle those ones. Any questions on that? Would you like to see another one or move on? It's going to be the same exact process.
Let's do it.
I agree.
Okay. All right, cool. So here, tangent alpha equals -4/3 between pi over 2 and pi, and cosine beta equals 1/2 between 0 and pi over 2. So again, let's do it all over. So for alpha, ugly alphas, we have the unit circle. And if we're stuck between pi and pi over 2, we must be in quadrant
2.
2. There's alpha. And if tangent is -4/3, how do I label this triangle?
Adjacent 4. Or no, opposite 4, adjacent third. -3.
Which means the hypotenuse has to be
5.
5. Beautiful. There it is.
Literally like the exact same alpha of the question.
It's the same one, right?
He said it was.
Literally the exact same, not the exact same question.
All right. Now beta is stuck between 0 and pi over 2. What quadrant are we in?
1.
1. There's beta. And if cosine is 1/2, this means what? What's my base?
Adjacent 1, hypotenuse.
1.
And height is
Also 1.
3.
is it? No, it would be 2
yeah,
squared
square root
minus
3.
1 squared. So 4
just do
minus
square root
1.
3.
So square root 3. Okay, there you go. All values are filled out. Now let's answer what it wants. A, what is the cosine of alpha?
Negative 3/5.
Negative 3/5. Good. What is the cosine of beta? We already have that, don't we?
1/2.
1/2. Good. Then what is the sum formula? So C, cosine of alpha plus beta, cosine alpha, cosine beta, minus sine alpha, sine beta. Okay, now piece it together. And what is the value of cosine at alpha?
Negative 3/5.
Negative 3/5. What's cosine at beta?
1/2.
1/2. Minus what's sine at alpha?
4/5.
4/5. And what is sine at beta?
Radical 3/2.
Good. And you get negative 3/10 minus 4 square root 3/10, which gives you negative 3 minus 4 square root 3/10. Boom, boom, boom.
Yeah, I just noticed. So the beta, isn't that actually on the unit circle itself?
What do you mean?
Like, isn't that actually quadrant run 1 of it?
Well, they're all on the unit circle. Alpha's on the unit circle, right? Or are you saying like the values are on the unit circle?
I guess the values, yeah.
Okay. Yeah, because 1/2 and square root of 3/2. Yes, those are numerical values on the unit circle. I get you now. Crazy, those connections. And then D, I'll do that up there. Sine alpha plus beta, so sine alpha cosine beta plus cosine alpha sine beta. And what is sine at alpha?
4/5.
4/5. What is cosine at beta?
1/2.
1/2. Plus, what's cosine at alpha?
Negative 3/5.
And what is sine at beta?
Square
Radical
root
3/2.
There you go. Ooh, we stole it from you. All right. 4/10 minus 3 square root 3/10. So 4 minus 3 square root 3/10. Beautiful.
I shouldn't ask us if you want us to do another one, because I'll probably say yes every time.
I was like, usually the answer is no, but yeah, I'll just be like, next time, just be like, we're skipping this because it's the exact same thing.
You're going to want him to prove this after the freaking lesson, aren't you?
Absolutely, yes. No, I'm like straight up down.
I'll be like, it's dinner time, sorry.
Next time.
All right, here we are going to do identities using the sum and difference formulas. So we want to show that cosine alpha minus beta over sine alpha sine beta is equal to cotangent alpha cotangent beta plus 1. Do you want to start on the left side or would you like to start on the right side?
Let's go left side.
Let's go left side. Cool.
Does it make a difference on which side you start on? Like,
hey man, it's identities. Did you watch the video yet?
The beginning of it, but not all of it.
Does this work the same way where you choose the most complicated one?
Exactly. I mean, you can choose left or right. It doesn't matter. But I mean, for this one, it would work either way. It works either way for all of them. But again, for identities, you always choose the more complicated looking side. And in this case, it's the left side, right?
I mean, they could both be considered complicated. Trying to
Yeah,
get tangent alpha, cotangent beta plus 1 to be the complicated looking one. Just
exactly. So trust me on this one. It would work both ways nicely. But we said left side. So let's go left side. So cosine alpha minus beta, we can expand that into the difference formula for cosine, right? So we're going to make it cosine alpha, cosine beta minus sine alpha, sine beta.
is that a plus though?
Is that
No.
plus?
Oh, is it? Yeah, it's plus. You're right. You're plus. And over sine alpha, sine beta. Now what?
Wait, give me like a minute, please. Don't do it.
All right. All right. I don't want to do that. I just want to get rid of that ugly plus sign. No, stop it. Zoom in. There we go. Let's see. Delete. Oh, whatever. There we go.
I
And
mean,
remember,
it took me
think
a long time, but
algebraically.
yeah, like, because, I mean, okay, so here's what I was gonna do, but then I'm like, nope, it's cotangent alpha, cotangent beta, because I mean, you can,
What were you gonna do?
out the sine alpha, sine beta, and then you have the cosine alpha, cosine beta plus 1, but that's not what we're looking for.
Yeah, it is. So you want to factor.
We're looking for cotangent alpha, cotangent beta.
Exactly. So you said, did you want to factor or did you want to cancel out the sine alphas?
I said cancel, but
Good. So go with that. And how would you cancel them?
I mean, they're the exact same expression.
Can we do this though?
Yeah. And then it's cosine alpha.
Can
You
we
can
do
because it has
that?
a plus, right?
Because it has a plus. Okay.
Remember, if they're held together by addition or subtraction, they're holding hands, right? Red Rover can't come over.
I need to remember that one. Red Rover.
So, but you're on to something. So how could I cancel it like that? Oh, what did I just do? Sorry. We're back at the beginning. Lesson's over.
What is your your little saying or pun to remember that?
What did I just say? If it's plus or minus, they're holding hands and Red Rover cannot come over. Because remember, Red Rover comes over and breaks up the line, right?
I had a depressing childhood and didn't play that game.
So you have to split them up somehow to break the line apart so Rover can come over.
So
I don't
you
know what
send
kids-
Rover over or what? Tim?
I don't know what kids play these days, okay? Fortnite, okay? I don't think kids even play outside anymore.
Yeah, no.
All right. So you're on the right track, Luis. So let's keep it simple. Like I said, algebraically, if I said x plus 1, if I said x plus 1 over x and I said split this up, what would you write?
Oh, x over x.
X plus 1 times.
Ah, duh. Well, so isn't that the same thing as? Okay. No.
Because now,
Now
can I legally cancel those x's?
Yes.
Yes.
And then you have the plus. That's the plus 1, and then.
There you go. So that's what we're gonna do here. We're gonna split this into two fractions. This is gonna be cosine alpha, cosine beta over sine alpha, sine beta plus sine alpha, sine beta over sine alpha, sine beta. And now what happens?
Will that just become 1?
Good. That becomes 1. And then we know that cosine over sine becomes what?
Cotangent.
And you can like split them up and then, you know, they're
Cotangent alpha. And we know that cosine beta over sine beta becomes
cotangent.
Cotangent beta.
plus
I'm telling you, I spent so much time on these identities this last weekend. It's crazy. Still can't do it.
And now, let's say you wanted to start from here. So here's a little cheat code for you. Start here, right? You start from the right side and just reverse the whole process. All right, we good with that?
Yes, sir.
All right.
Yeah.
Hey, that was fun, right? Like, sure. Okay. Now, B. Prove that sine of pi over 2 plus theta is equal to cosine. You want to start with the left side or the right side?
Let's go right side.
Oh, God, right side. No, thank you. You might have to, but it could work if you use complementary angle theorem on the right side.
Wait, remind me, complementary angle theorem was.
So remember, if it was sine theta, it would be cosine of,
90
since this is in
Oh,
radians, it would be cosine of pi over 2 minus theta.
Okay.
So if you did cosine theta, you could use sine of pi over 2 minus theta, and then use the difference formula for sine, and hopefully it would get you here.
I'm not trying to say that this one is you know, ahead of me, but that's something my mind would not even have ever thought of. So.
I'm telling you, everything's connected. Like Ethan forgetting even and odd properties.
Appreciate that.
Yeah, you're welcome. That's what I said. Don't forget the other stuff we learned because it's all connected, right? All right, so we're going to do the sum formula for this one. And you get sine of pi over 2 times cosine theta. And here you get cosine of pi over 2 times sine theta. Okay, well, what is sine at pi over 2?
Square root 2 over 2?
Pi over 2.
Oh, sorry, 1.
1 times the cosine of theta plus, what is cosine at pi over 2?
0.
0. So what are we left with? What's 1 times cosine?
0 times sine is 0, and you're left with cosine theta.
I'm a little confused on how you split that top part up.
The sum formula for sine, what we learned today.
Oh, okay, I see it now. I don't know why I was thinking of the cosine.
I was thinking like identities for some reason, and I'm like, how do I split this up? But then it's like, wait, we just learned some point.
We just, yes, we just learned it. All right, cool. That was minus, nope. Okay, move on.
That
Okay.
was minus. Wait, no.
No, I was saying if we try to do it the way I showed you with the complementary angle, would it work? I don't think it would, but we'd have to explore it more, which we're not. Let's keep going. All right. So now, of course, if we have sum and difference formulas for sine and cosine, we definitely have them for tangent. So here are the sum formulas and difference formulas for tangent. Tangent alpha plus beta is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. And tangent alpha minus beta is tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. All right. So some differences, right? Plus, but a minus in the bottom, and then minus, but a plus in the bottom. So let's go ahead and use these formulas to prove more identities. It says prove that tangent theta plus pi is equal to tangent theta. Okay, well, we're going to start with the left side, right? And tangent theta plus pi, using the sum formula for tangent, is going to give me tangent theta plus tangent at pi over 1 minus tangent theta times tangent at pi. Okay, well, what is the value of tangent at pi?
0.
Good. You get plus 0 over 1 minus the tangent of theta times 0. And this will just leave you with tangent theta over 1, or just tangent. All right, cool. Next one. Prove that tangent theta plus 2 plus pi over 2 is equal to negative cotangent. So we will use the sum formula again. Left. Tangent theta plus pi over 2 will give you tangent theta plus the tangent at pi over 2 over 1 minus tangent theta times tangent at pi over 2. What is the value of tangent at pi over 2?
What? Dang it, no, I'm doing that pi over 4 thing again.
0.
What are the coordinates? What are the coordinates at pi over 2?
0, 1.
0, 1. And
That's
tangent,
undefined.
good. Tangent puts y over x, right? Tangent puts 1 over 0, which is undefined. So this is not going to work, which means we have to think of another possibility.
Or it's root?
Can we
Or it's
go
what?
right?
I wouldn't do the right. That's going to be way more difficult. How about we think of identities? Tangent is what identity?
Sine over cosine.
So why not use that? Tangent of theta plus pi over 2 can be rewritten as sine of theta plus pi over 2 over cosine of theta plus pi over 2. Crazy, I know. And now you can use the sum formulas for sine and cosine. So this will give you sine theta cosine of pi over 2 plus cosine theta sine of pi over 2 over cosine theta cosine pi over 2 minus sine theta sine pi over 2. Now, what is the value of cosine at pi over 2?
0.
0. I'll just put 0. Plus cosine theta times, what is the value of sine at pi over 2?
1.
1.
1. Over cosine theta times, what is cosine at pi over 2?
0.
0.
Oh, wait, 0. No, sine.
Minus sine theta times, again, sine at pi over 2?
1.
1. What are we left with?
Cosine theta over sine theta, or negative sine theta,
Which is equal to?
negative cotangent theta.
There you go.
Proven.
Wow. Wow. Wow.
Wowza.
Wow. All right. Everybody good with that page?
Stuff's not bad.
It's a bunch of fun, right? All right. We're almost there. We're almost there. Okay, 3 more. Let's do this. Okay. So use the sum and difference formulas to find the exact value of sine of the inverse cosine of 1/2 and the inverse plus the inverse sine of 3/5. So here we're going to use the sum and difference formula, but we're going to have to make substitutions. Remember 8.2 when we had, what was it? Sine of the inverse tangent of like 1/2. And we had to make that substitution, let theta equal the inside.
Yeah.
Yeah, that's what we're going to do here. So what we're going to do is let alpha equal the inverse cosine and let beta equal the inverse sine. And we are now going to make unit circles for each of these functions to find out the values of alpha and beta. So here we go. We'll start with alpha. Alpha equals the inverse cosine of 1/2. Then we apply the inverse to both sides, and we get cosine alpha equals 1/2 on what interval?
0 to pi.
Good. Which means now we can make a unit circle from 0 to pi. And if cosine is 1/2, what quadrant are we in?
1.
So here's where alpha is. And if cosine is 1/2, the base is 1, the hypotenuse is 2, and y is, or the height is going to be
Square root 3.
square root 3. There we go. We found all the information for alpha. Now let's do the same for beta. Beta equals the inverse sine of 3/5. Apply the inverse to both sides. And sine beta equals 3/5 on what interval?
Negative pi over 2 to pi over 2.
Good. Unit circle. There's negative pi over 2. There's pi over 2. There's 0. And if sine is a positive 3/5, we must be in quadrant
1.
1. There's beta. And if sine is 3/5, the height is 3, the hypotenuse is 5, and the base must be
4.
4. There we go. That's all the information for alpha and beta, which means we come back to our substitution. And now if you look at the above, this now becomes sine of alpha plus beta. Now alpha and beta, they are these right triangles in their correct quadrants, which means we now use the sum formula. For sine, you get sine alpha times cosine beta plus cosine alpha times sine beta. And looking at our triangles, what is the sine of alpha?
Square root 3 over 2.
Square root 3 over 2. What is the cosine of beta?
4/5.
4
Yeah.
fifths. What is the cosine of alpha? That's given already, right?
1/2. Yeah.
And what's the sine of beta? Hey, that's given.
3/5.
3 fifths. 4 square root 3 over 10 plus 3 tenths. And you get 4 square root 3 plus 3 over 10. That was great. Any questions on that?
I was like all good until we got to like, because I was like, how do you replace the values in there? But alpha and beta, that's super tricky.
You got it now?
Yeah.
All right. We have the time. This is exactly like that. So sure, let's do it. Here's the cosine of the inverse tangent of 4/3 plus the inverse cosine of 5/13. So we do the same. Let alpha equal the inverse tangent of 4/3. Apply the inverse to both sides, and you get tangent alpha equals 4/3 on what interval?
Negative pi over 2 to pi over 2.
There you go.
But it's not going to can't equal to it, right?
Exactly. There's negative pi over 2. There's pi over 2 and 0. And if we are a positive 4/3, we must be in quadrant
1.
1. There's alpha. And if tangent's 4/3, that means the height is 4, the base is 3, and the hypotenuse must be
5.
5. Good. Beta equals the inverse cosine of 5/13. Apply the inverse to both sides, and you get 5/13 on that interval. We already saw it. 0 to pi, right? Unit circle. There's 0. There's pi. If we are a positive 5/13, we must be again in quadrant
1.
1. There's beta. And if cosine is 5/13, the base is 5, the hypotenuse is 13th, and what is the height?
12.
12. There you go. Perfect. There's all the information we need. And now we come back to our substitution, which means you're going to get cosine of alpha plus beta, which gives us cosine alpha, cosine beta, minus sine alpha, sine beta. Okay. And looking at our triangles, what is the cosine of alpha?
Third fifths.
3/5. What's the cosine of beta? Well, that's given.
5/13.
Minus, what is the sine of alpha?
4/5.
4/5. And what's the sine of beta?
12/13.
There we go. Perfect. Put it together. That's 15 over, what's 5 times 13?
65.
Well, those should cancel, right?
65. What should cancel? Oh, those fives?
Don't do
Ah,
that.
yeah, you are right,
Don't
but
do
I
that.
wouldn't do that
Yeah.
because you're going to have to add it to the fraction on the right. So if you cancel those fives right now, you're going to have to get common denominators.
Good point.
And get back to the 65.
Good eye, though. Good eye. And 15 over 65 minus 48 over 65 gives me
Negative 33 over 65.
boom, boom, boom. Yeehaw. Oh, man. All right.
Just too much.
All good?
Ready for a nap.
All right. Last one, right? My goodness, we made it. Okay. So here we're going to write an algebraic expression in terms of u and v. So this is basically doing what we just did on the last two problems, except now there's no numbers involved, just letters. So let's do it. Here we want to find sine of the inverse sine of u plus inverse cosine of v. And once again, let alpha equal the inverse sine of u. Apply the inverse to both sides. Nope, not the inverse, not the actual, the inverse of the inverse. And you get sine alpha equals u on negative pi over 2 to pi over 2. Unit circle time. There's negative pi over 2. Here's pi over 2. And if sine is a positive u, then we're definitely
One.
quadrant 1. So here's alpha. And now you have to make u into a fraction. You're going to put u over 1, which means that the height of the triangle is u. The hypotenuse is 1. And what would the base be?
Square root 1 minus u squared.
Very good. Now do the same for beta. Beta equals the inverse cosine of v. Apply the inverse to both sides. 0 to pi. Here we go. Here we go. There's 0. There's pi. We're definitely in quadrant 1 because v is positive. Here is b. And put v over 1. And this means that the base is v. Hypotenuse is 1. And what would the height be?
Radical 1 minus b squared.
There you go. Which means we're now ready to come back to our substitution, which is sine of alpha plus beta. And sum formula, sine alpha, cosine beta, plus cosine alpha, sine beta. And what is the value of sine at alpha?
U.
U. Me? And what is cosine at beta?
V.
V. And plus, what is cosine at alpha?
Square root 1 minus u squared.
Good. And what is sine at beta?
Square root 1 minus v squared.
There you go. And that should be finished.
I was wondering, can you simplify it any further? No, right?
You could foil the insides, but I don't think that would get you anywhere. You could rewrite it as this. But that should be most of what you can do.
Oh yeah, because you are multiplying them. True.
If you did foil them, you'd get 1 minus v squared minus u squared plus u squared v squared, which would get us nowhere.
So my math lab should take that at the very first one.
Yeah.
It only takes the last one.
And that's how you break your computer.
Yeah. Actually, yeah, I don't know if it'll take that one. Sorry. It might take that. If not, it'll take this one. But hey, that's why you get multiple tries, right? All right.
You know what time it is?
All right. It's dinner time.
No, it's time to proof that tangent.
Boy.
Subtraction. That looks like the
You
most.
shut your mouth.
All right. So here we are done with 8.5. Anybody have questions over this?
Did you
Anybody-
say it's like 45 minutes for like each one, or it would take like 45 minutes to do all of them?
to do the main one, but maybe we could speed it up for you. But here, I guess we're done with this. So